When you look at one of these hearts, is first find out where the anterior side is and where the posterior side is, right? That's right here, the posterior side, and this is the anterior side. That makes this the apex of the heart. It makes everything on this side the right side and everything on this side the left side of the heart, okay? Then the next thing you're going to look for is these little auricles up here, which is indications of the left atrium and underneath it, and the right atrium beneath that one. The way I teach this is we work as if we're a red blood cell. Pretend we're a red blood cell, and we're going to start in superior inferior vena cava. So it's on the practical, if you see a picture of the heart like this, and we have a little piece of tape right here, you'll say superior vena cava. If we have a little piece of tape on this side, you'd say inferior vena cava, okay? So if you remember, the flow of blood goes from superior vena cava, inferior vena cava to the right atrium. See how it goes to the right atrium? From the right atrium, it goes through the what valve? Tricuspid valve to the right ventricle. You see where my probe is? That's the right ventricle right there. That makes this the anterior interventricular groove or sulcus, right here. That separates the right ventricle from the left ventricle. You can tell just by looking at it how much bigger this one is compared to this one right here. So we had superior inferior vena cava going into the right atrium through the tricuspid valve to the right ventricle. Once it goes out the right ventricle, it pumps up and it goes through the pulmonary trunk. Let's see if I have one. I don't really have a pulmonary trunk. See how mine is cut so close to there's not one. You guys had better ones. But it goes from the right ventricle out the pulmonary semilunar valve to the pulmonary artery, goes away, goes to the lungs, gets oxygen, goes back via the pulmonary vein to the left atrium, which see how these are cut so close. Oh, and this one as well, you can't see the vessels at all. So on a practical, we would just usually we do left atrium, left ventricle, right ventricle, anterior interventricular groove or sulcus, atrioventricular groove or sulcus, anterior atrioventricular groove or sulcus, posterior atrioventricular groove or sulcus, and posterior interventricular groove or sulcus.
Would you want us to write all that out, or can we abbreviate it, pick?
You have to write it out. Yeah, you have to write it all out.
Correctly.
You have to spell it correctly. Yeah.
That's why I was wondering about the abbreviation.
Yeah. Okay, so we go superior inferior vena cava to the right atrium, from the right atrium through the tricuspid valve to the right ventricle, out the right ventricle to the pulmonary semilunar valve, to the lungs, back to the heart, the pulmonary veins, to the left atrium, but through the left atrium through what valve? Bicuspid valve, through the left ventricle. Feel where that goes? Goes to the left ventricle. And then it goes from the left ventricle out through the aortic semilunar valve to the aorta. Right there. You see my little probe? Goes up here. Now, I'm going to tell you something interesting about sheep. Sheepies. There's the arch of the aorta. The aorta comes up like this and then branches off into 3 branches. Like this in the human. This is the BCS. And I tried to figure out some new acronyms to help you remember BCS. I learned it as the Bowl Championship Series. If you're into football, college football, Bowl Championship Series, you could do behavioral or cognitive services. If you're working in the lab, it's called a biochemistry survey, BCS. A biochemistry survey is BCS. This is a brachiocephalic common carotid subclavian. Okay, there's 3 branches off of the human. You'll learn that when you create your 3D model. Now on the sheep, instead of being BCS, so instead of being BCS coming off here, all we have is
BS.
Yeah, you get it? So all you have in a sheet is BS.
Yes.
So you'll never know when you're going to be asked on a practical, what's the difference between the sheep heart and the human heart? Well, one is that it has BS. Right? Brachiocephalic and subclavian. Now the other thing is when they tell you to cut it, they tell you to cut it a certain way, which I don't like. I just want to cut right straight down and cut it in half.
Oh, damn. Oh,
It's a little easier. A little easier.
So it's okay for us to cut it in half?
Yeah, it's okay to cut it in half.
All the way like that?
Yeah.
Yeah, it's like,
This is not
don't
too
cut through it,
specifically.
open it
Yeah.
up like a clam.
Open it up like a clam, exactly. That's the easiest way, I think. So then we go back, we look at it again, just to review. Wait, where's my, whoa, where did my little thing go? There it is. Superior and inferior vena cava to the right atrium, out the right atrium through the bicuspid or the tricuspid valve to the right ventricle. And see when I open this up now, you can see that it's on the right side. See this side right here is thicker than this side right there. That makes that the right ventricle, and this one over here, the left ventricle. You can see how much bigger the left ventricle is compared to the right ventricle. And it just depends on where you cut it as to what they look like. So we go superior inferior vena cava to the right atrium through the tricuspid valve to the right ventricle. We did out the right ventricle through the pulmonary semilunar valve. Get in there. See how, just to make sure we're on the correct side. So this is going through the pulmonary semilunar valve, which you guys were asked to dissect for it. It's kind of hard to dissect for them. As you learn, they tend to just kind of get chewed up real easily, so you don't see them. So the aortic semilunar valve the pulmonary semilunar valve to the lungs, back from the lungs to the pulmonary veins to the left atrium through the bicuspid valve to the left ventricle. See how I'm on this side now. So it just lets me know that we're doing it right. Now for the dissected sheep, the things that you really want to be able to know about are the things I was pointing out before, like here's the apex of the heart, right? Here's the interventricular groove or sulcus. Here's the posterior atrioventricular groove or sulcus. Notice the difference in atrioventricular groove and an interventricular, between the ventricles, ventricular groove. Apex, left atrium, right atrium. And then when we open it up on the inside, this wasn't the best heart for this to show you. You can see the little chordae tendineae, which is what this is right here, this little, right there. Those are called chordae tendineae, and they attach to the papillary muscle.
Do they call those your heartstrings or something?
The heartstrings, yeah, exactly, yeah. Those are your heartstrings, the tug on the heartstrings. So then they are attached to something called a papillary muscle right there, and it keeps the valves open so that the lub is dub, and they go lub, and then the pressure builds up, and then the aortic semilunar valves open, and then whenever they close, they go dub, like that. Did I spill any blood all over you, did I? Okay, good.
And they keep it from backflowing too,
Keep
right?
it from backflowing too, yeah. So when we learn the human heart, the human model, learn all of those other little details like the pulmonary veins, pulmonary arteries, a pulmonary trunk, ascending aorta, arch of aorta, descending aorta, brachiocephalic common carotid subclavian, the BCS off of it. On the sheep heart, if we were to ever put something in like this, remember the BS? This would be the brachiocephalic and subclavian. If I were to point to, well, if this had a pulmonary trunk, where's my pulmonary trunk? There it is. If it had a pulmonary trunk, you'd see it going through. We sometimes put a rod through there and you would say pulmonary trunk. Those are the kind of things that you would see on the dissected heart. Okay, not all the details that you would see on the human heart. So just make sure that you can see all those things and then you're fine. Okay, does that sound good? All right.
Can you